class, and welcome to section 10.8, which is all about trigonometric ratios. By the end of today's lesson, you'll be able to find the three trig values for the angle. Use a calculator to find to find trig values. Use ratios to find missing sides or missing angles, and then use trig ratios to complete the triangles. So, trigonometry is the study of relationships among the side and angles of triangles. This is going to be hugely important for you when you get to geometry, as trig can help you find a lot of information about a shape, because most shapes can be broken down into the most basic piece of a triangle. So a trigonometric ratio is a ratio that compares the side length of two sides of a right triangle. So everything in trig is based off a right triangle, like the one you see down here on the left. Again, C is our right angle, and notice how C is also the label of our hypotenuse. Notice that angle A is opposite from side A, and angle B is opposite from side B. So what that means by opposite is that you could draw a straight line from the angle to the side. When we talk about our trig ratios, there are three of them. First, the sine is talking about the opposite over the hypotenuse. So the opposite value over the hypotenuse value. So if I'm looking at the sine of A, I'm looking at the value opposite of A, which is A, over the hypotenuse, which is C. So sine of A is A over C. Cosine is our next value, and that is adjacent, which means touching the angle over the hypotenuse. So if we're looking at the cosine of A, I want side B, that adjacent side that's touching the angle, so B over the hypotenuse. So again, cosine of A is B over the hypotenuse. Last one is tangent. That stands for opposite over the adjacent. So if we're looking at the tangent of A, we want the value opposite of angle A, which is A, and the value adjacent to A, which is B. So tangent of A is A over B. You could go through and find the sine, cosine, and tangent of both angles B and C. And that is what we are going to start with. So we're going to find the three trig values for angle A. In order to do this, the first thing we need to know is how long that last side is. This is where Pythagorean theorem comes in handy. So I'm going to say 9 squared plus b squared is equal to 15 squared. 9 squared is 81. B squared stays put. 15 squared is 225. I'm going to go ahead and subtract 81 from both sides in order to continue solving for b. So I get that b squared is equal to 144. Taking the square root, I get a value for b of 12. So that last side we have is 12. Now, we are looking for the values in relation to angle A. So this angle down here in the corner. So first, we're going to have sine of A. So we're going opposite, which is 9, over the hypotenuse, which is 15. So we got sine of A is equal to 9 over 15. That can be reduced by dividing both by 3. So I get 3 over 5. Next one I'm going to look at is the cosine of A. So that's the adjacent, so the side that's touching A, and the hypotenuse. So in this case, it's going to be 12 over 15. Again, those can be reduced by dividing by 3. So I'm going to end up with 4 over 5. The last value we're looking for is the tangent of A. That's taking the opposite over the adjacent. So in this case, that opposite value is 9. The adjacent value is 12. Again, both of them can be divided by 3. So I've got the tangent of A is equal to 3 over 4. So my three values, sine of A is equal to 3/5, cosine of A is equal to 4/5, and tangent of A is equal to 3/4. Go ahead and try this one on your own. Same triangle, but now you are looking for the trig values for angle B. So we got 12 over 15 for the sine, which reduces to 4/5. Cosine is 3/5, and the tangent is 4/3. Next thing we're going to do is we're going to use the calculator to just find these values. So you'll notice in your calculator there are 3 buttons: sine, cosine, and tangent. When you hit the sine button, you're going to get sine with a parentheses. In this case, you're going to type in 47, close the parentheses, and hit enter. That is going to give you the decimal version of that fraction that it would be equal to. So the sine of an angle that is 47 degrees is 0.73. Then with cosine, you're going to hit the cosine button, type in 56, close the parentheses, and that's going to give you 0.56. Last one we're going to try is tangent of 81, close that parentheses, and you're going to end up with 6.31. If you do not have one of the calculators from class at home, that's totally fine. If you go into Google and type calculator into Google, it will pull up a calculator that has the sine, cosine, and tangent options available to you. So you can still work on this at home even if you do not have one of the calculators from class. Go ahead and try these 3 on your own. We end up with 0.96, 0.42, and 0.32. Next thing we're going to do is we are going to use trig values to help us find the missing side. So what we've got here, we've got an angle measurement of 10. We want to be aware of what values we have in relation to that angle. So in this case, that h value is opposite, and the 5 value is the hypotenuse. When we have opposite and hypotenuse, that means we have sine. So opposite and hypotenuse is sine. So I'm going to go ahead and say the sine of 10 is going to equal the opposite, which is h, over the hypotenuse, which is 5. I can plug that sine of 10 into my calculator, and I get a value of 0.17. So now I have h over 5 is equal to 0.17. We know how to solve that equation. To get rid of divide by 5, we multiply by 5. And I get a final answer of h is equal to 0.87. So I took that value, solved for it in my calculator, and then multiplied by 5 to get rid of divide by 5. Go ahead and try this one on your own. In this case, you had the opposite side and the adjacent side. So that means you're using tangent. So you would take tangent of 25 is equal to the opposite, which is x, over 14, getting a value of 0.47 and multiplying by 14, the final answer is 6.53. When we are looking for missing angles, again, we are going to use our idea of trig ratios. So we're looking at angle y here. In relation to angle y, I have the adjacent side and I have the hypotenuse side. Adjacent and hypotenuse is cosine. So I'm going to say the cosine of y, because I don't know how big that angle is equal to adjacent over hypotenuse, or 8 over 19. So I'm going to take now the cosine of y is equal to 0.42. I'm going to do that division. 8 divided by 19 is 0.42. If you are using one of the calculators from class, you're going to hit that blue button, and then you're going to hit cosine. And it's going to give you something that looks like this. Cosine with a little -1. That means to undo the cosine value. We call it inverse. So just like addition undoes subtraction, division undoes multiplication, squaring undoes a square root. The opposite of cosine is the inverse cosine. That's what that little -1 is. So you would hit inverse cosine of 0.42, and you would get an answer of 65.17 degrees. So 65.17 degrees. That is how big this angle measurement is. Go ahead and try this one on your own. In this case, we're looking at angle A. I have the adjacent side and the hypotenuse side, which is cosine. So I've got cosine of A is equal to 16 over 36. Dividing, I get 0.4 repeating. Taking the inverse cosine of 0.44, I get an angle of 63.61 degrees. Last thing that you'll be doing in this section is solving the triangle. This means that you need to find all three angles and all three sides. In this case, the easy thing to start with is to find the missing angle. We know that triangles have to add up to 180 degrees. So right now I am missing angle A, and I have the other two. So I've got a 41 plus a 90 plus A is going to equal 180. 41 and 90 gives me 131 plus A is equal to 180. So our angle A after I subtract 131 is going to be 49 degrees. So angle A is equal to 49 degrees. That's the first piece of our triangle that was missing. Next, I need to find the values for A or for C. A quick side note before I start that. Angles should always be identified with the capital letters, and the sides are going to be identified with the lowercase letters. My apologies for that mistake. So, we can now use any of our angles and any of our trig ratios to help us find those missing sides. Since they gave us angle 41, I'm going to go ahead and use angle 41 as my base angle. So to find A, to find the value of A, I am looking at the adjacent over the the adjacent and the opposite, because we have the value of 6. So I'm going to go ahead and say the tangent of 41 is equal to the opposite, which is 6, over the adjacent, which is A. Tangent of 41 gives me 0.87, which is currently equal to 6 over A. To get rid of the A on the bottom, I'm going to multiply both sides by A. So I've got 0.87A is equal to 6. To solve that problem, I'm going to divide both sides by 0.87, and I'm going to get an A value of 6.90. Then I need to go through and I need to find side C. Side C is the hypotenuse. So again, they gave us a measurement of 6 for the opposite of 41 and the hypotenuse. Opposite and hypotenuse are sine. So the sine of 41 is equal to 6 over C. The sine of 41 is 0.66. To get rid of the C in the bottom, I'm going to multiply both sides by C. So I have 0.66C is equal to 6. Dividing by 0.66 on both sides, I end up with an answer of C is equal to 9.09. Go ahead and try this one on your own. Angle B is going to be 55 degrees, 180 minus 90 minus 35. They gave us angle 35 as our base angle, so I'm going to say the sine of 35 is equal to A over 7 for the opposite over the hypotenuse. Solving that problem, we get an A value of 4.02. Again, for B, we're missing the adjacent side, so we're going to use cosine of 35 is equal to B over 7, which is the hypotenuse. Solving, we get an answer of 5.73. If you have questions about this or anything else from the lesson, please let me know when you get to class.